All right, so today is one of it's an interesting chapter, and it's about the principles of package coupling and cohesion. All right, so we're going to be looking at some principles of package coupling and cohesion. In particular, we're going to be looking at two principles of package cohesion. They are the common closure principle, the common reuse principle, the CCP and the CRP. And we're going to be introducing also three principles at the coupling level. Okay. And with this, let me just step out here for a second. I know I've mentioned this before when I was describing the walkthrough for the project, but let me just go through this again. Let me share the screen. All right. Okay. So when you have a package, okay, as such, and you have another package, and in it there's some classes, okay, and then between the other one there's also some other classes as well, okay. The associations between the classes in that package, this is called cohesion, okay. Now it's cohesion because it's inside a package, all right, whereas the connections between classes that are between different packages, this is called a coupling. Okay, technically they're exactly the same thing. Okay, so coupling is between packages. Okay, in general, what this is, when a class is associated with another class, okay. For example, let's just say there's a directed association. I know I've covered this before when we did static modeling. That means in the code for class A, there is a variable B that it has access to. So we can navigate, do B dot, variable, or B dot some function. All right. So this is what package coupling is and what package cohesion is. All right. Now what we want to do is we want to increase the cohesion as much as we can. All right. And also what we want to do is we want to decrease the coupling as much as we can. Now, in general, classes that belong together because of some logical aspect related to the domain should be together, and they should have connection with each other. If you don't have connections with each other, then chances are they shouldn't have been together to begin with. Okay. Now, for example, I think I mentioned this before. I have, let's just say, a registration subsystem and an accounting subsystem. Yeah, there is some relation between them, but in general, most of the classes that relate to the registration are not related to and not associated with the classes that are dealing with the accounting subsystem. So if you put half of the classes of the accounting with the other half of registration in a single package, you won't find there's a lot of cohesion. Okay. And again, this lack of cohesion is the symptom. It's not the problem in itself, it's the symptom. Okay, symptom of what? What's the root cause? The root cause is we shoved a number of classes that shouldn't belong together and we made them be in one class. All right. Just give me a moment, guys. Just let me stop here for a second. Recording. So to recap, what is it that we want to do with cohesion? Do we want more or do we want less? Say out loud. Say it proud. Or text it, I suppose. Yes, good. And coupling, do we want more or do we want less? Exactly, okay. So once again, just to recap, coupling is the association between classes, between the different packages, whereas the cohesion is the association between classes within the same package. We want cohesion to be as high as we can and coupling to be as low as we can. All right, so this is the general concept. This is the general motto. So let me switch back again to the slides. All right. Now, when we are looking at the cohesion aspect, when we're looking at the cohesion aspect, there are two principles that we're going to be covering today. And when we're looking at the coupling aspect, like relationship between different, sorry, I sneezed. Relation between classes that are between different packages, we're going to look at three different principles: the acyclic dependencies principle, the stable principles, the stable dependencies principles, and the stable abstractions principles. Okay, all of them are very, very simple. All of them are pretty clear. So let's get started with the first one. Okay, so for the principles of package cohesion, we got two. We got the common closure principle and the common reuse principle. Now, the common closure principle says that classes that change together belong together. Now, the whole point is, if a class, when it changes, it ends up requiring another class to change, or it requires another class to change, and they tend to change together, it means that there's a dependency on each other, and that they're really, really related to each other, to the point that, you know, if you make an update here, chances are you're going to need to make an update there, and an update there, and so on. Okay. Now, what we want to do is we want to be able to manage and test the release of the package, which is a non-trivial activity. Now, what is the releasing? Releasing means you got to be able to compile a set of class or classes before it's out there and it's ready for execution. Okay. Now, in the programs that you've been creating back in SE100 and SE120, these tend to be simple programs, all of them in one package. Maybe you got some few packages here and there, but with bigger systems, this is not the case. So sometimes you need actually a release strategy. Okay, a release strategy means we're going to compile this first, we're going to compile that next, we're going to compile this, and then you got teams working on different subsystems and different packages. So you can't just ask this one team to stop while I freeze this one, and so on and so forth, right? Now, what we want to do is we want to reduce the amount of work that we have. So basically we say is, like, if I have those classes that I know if I change A, I'm going to change B, I'm going to change C. And I have A in package 1, B in package 2, and C in package 3. That means that if I change package A, class A, I'm going to end up redeploying and re-releasing package 1, which also means I'm going to be re-releasing package 2 because it has class B, which means I'm also going to be re-releasing package 3 that has class C. Okay. Now, the point is, if I know once A changes, it's going to change B and C, why don't I just put them all together into one package? Okay. This way, I've reduced the number of packages, all right, into one package. I've reduced the number of packages. I reduced the number of packages where the classes exist. All right. In the meantime, of course, if those classes don't happen to change together, then there's no point in shoving it all together into one package. Okay. Now, I'm not sure if this is clear. Let me draw this again visually. I probably should have started off visually to begin with. You have a question? Yeah. Cohesion. Now we're talking about cohesion. Okay. Okay. So basically, guys, okay, so I got class A, I got three classes, A, B, and C. Okay. When one changes, it triggers the next one to change, triggers that one to change. Okay. Now, when it comes to the world of releasing, okay, and I have packages as such, okay, what I want to do is I want to minimize the number of packages that I have to redeploy, recompile, and redeploy. So if I deploy just one, recompile just one, it's better than two, it's better than three. Okay, worst case scenario, I have to redeploy and recompile everything. Okay, the easiest thing to do is to have just one package to redeploy and recompile and redeploy. Okay, now if I, for some reason, for some silly reason, I spread the A, B, and C over here, and I know beforehand that when A changes, it's going to trigger this one to change, which is going to trigger the C to change, then I'm going to end up with the worst case scenario of having to recompile all of them. However, if we had the three packages over here, and I know ahead of time that A and B and C, they're all going to trigger a change for each other, why don't I just put A, B, and C all together in the same package. This way, when a change does happen and it triggers an update on all three of them, all I have to do is recompile that one and that one only. Okay. Now let's take it to the nth degree. The nth degree. Oops. I actually can't spell the word degree. Okay. If I have a whole bunch of classes, all right. Now let me pick your brain on this one. What is the lazy and easiest way, the theoretical way, that I would guarantee myself that I'm going to be redeploying and recompiling the minimum number of packages when a change happens into one of these classes? How should I spread those classes into how many packages? What do you guys think? One, exactly, right? So if I make one big fat package over here and I grab all of these classes, all right, and I shove them all in here, that means doesn't matter if this class is using this one or sort of touching that one or not, or if it's gonna update that one. But bottom line is, in theory, if all of them are in the same package, then all I have to do is recompile and redeploy one package. Okay, that's the nth degree situation. Let's just keep that in mind for a moment. Okay, now we're gonna switch back again to the chapter. But before I actually move, everybody understood the common closure principle, guys, before I move on? Is it clear? All right, so classes that change together, they should belong together. Now, there we go. Okay, good. Now, next up, we have something called the common reuse principle. Again, it's still within the same cohesion level. Okay, now basically that principle says classes that are not reused together should not be grouped together. Okay, now if you walk into a supermarket, all right, and you want to buy a drink, you don't want to be confined by those big packages of sets of 24 drinks. Okay, let's just say you're buying a Pepsi. Okay, from your point of view, you say, I want the most flexibility. Okay, let the cans be isolated from each other. Don't package them together into one box, so that if I want one, I'll pick one. I don't have to pick the other 23. And if I want 24, I'll just pick 24. Okay. Even though, however, if I know for some reason that I always drink 24 at a time, and I always buy 24 at a time, then having that big box is not really something that hurts. Okay. But coming back to the first scenario, which is that the second one is unlikely, chances are sometimes you need just the one can, maybe two cans of Pepsi. You don't want the whole 24. Okay. And if you walk into a store and you realize that it's just big sets of 24, you might be discouraged from buying to begin with. Okay. Now, what this principle is saying is saying that classes that aren't reused together should not be grouped together. Now, what that means is, if I grab what's it called? If I grab a class, if I want to grab a package, and that package has 5 classes, and really I just wanted the one class from that package. Okay, remember they are cohesively stuck together. I just wanted the one class from the 5 classes in that package. All right, let me actually go to the white screen again. So that I just, okay. So here I am, I got my package over here, and I got this 5 classes that connected with each other and all that stuff. Right now, I'm really interested in this one over here. Okay, but I gotta pick up the whole package because it's one cohesive unit. Okay, it's like a TV. You can't just buy the screen without buying the remote control. You just gotta buy the whole thing. Okay, but really, you just wanted the remote control. What you end up with, you end up in a situation where you're taking a whole bunch of other things that you didn't really want. Okay, so unless I know for a fact that those other 5 are, when I get to use this one in the green, I'm actually going to be using those as well, then putting them in the same package have hurt me, because when I wanted to reuse the one in green, I ended up taking with me 5 other classes that I didn't want. Okay. So in order to improve the flexibility, okay, I got classes A, B, C, D, and E. And let's just say each one of them, all 5, none of them requires that when if you pick one, you have to pick the other one as well. Then the best way I should structure them or spread them across packages would be how? What would be the best way to do it? So that when I pick a package, I don't end up picking other classes that I don't need. Exactly. We put each class in a package. Okay, perfect. Okay, so I got A over here, I got B over here, I got C over here, D, and E. All right, and this way, had I wanted A, right, then I'll just pick it. I wanted B, I'll just pick it. Okay, now again, if I know A and B, I know they belong together. I know when if I'm gonna take A and use it in a different application, I have to take B with me as well. Then it doesn't hurt having A and B at the same time in the same package. But if that's not the case, if they're not reused together, then I should actually want to have them in different packages. Okay, so to the nth degree, okay, I have 9 classes. How many packages should I have? Okay, 9. And 9 satisfies that principle to the nth degree. Okay, so the RCP, the CRP, the common reuse principle, which is this one, wants packages to be as small as possible. To the nth degree, every class in a package on its own. The CCP, which we've covered a few moments ago, the common closure principle, actually wants us to shove all the classes into the same package. So to have package to be as big as possible, that's actually as, to the nth degree, I would have just the one package with all the classes in it, okay? Obviously, this is an nth degree, is an extreme situation. This too is also another extreme situation. What really happens is neither. I mean, basically what you do is, and it tends to conform to the logics, is that you're gonna end up having the logic of the domain dictate saying, well, these classes belong to the functionalities of registration. They should belong together. Okay, you realize this. Now, if class A and class B and class C, they all relate to registration. Okay, then it's common. It makes sense that if I reuse A, I'm gonna need to reuse B. I'm gonna need to reuse C as well. And if I make a changes A in A, I'm gonna need to make change in B. I'm gonna make to change in C as well. Okay. Now, when you are developing, maybe what you should do to make life simple is put everything together in the same package. So kind of like adhere and appease to the CCP principle. Okay, so I don't have to worry about the deployment of packages. Okay, make everything in the one big default main package. And then after I've finished development and after I'm done with my classes, then I can start to divide the classes into different packages, into different subsystems, according to the principles of CRP at this point. So I look at them and I say, which ones are so close to each other that if I happen to reuse one and then pick it up and I use it in a different subsystem, in a different system, that I would need to take its brothers and sisters with it as well. And those would be the ones that I would keep together in a package, while the other ones I would break them off into different packages. All right. Okay, guys, is this clear for everyone? Guys at home? Is it guys home? Is anybody listening at home? Okay. All right, moving on then. So now we're gonna look at, oh, there's somebody's on the message. Okay, thank you. We're gonna look at the the principles of package coupling. Okay, now we're gonna look at the different principles where packages are related to each other. Okay, gonna look at three of them specifically. First of is the acyclic dependencies principle, and the second one is the stable dependence principle, and the third is the stable abstractions principle. All right. Now, the acyclic dependence principle said means that the dependencies between the different packages shouldn't perform a cycle. Okay, because it makes sense. If package A requires package B, right, to be compiled and make sure the syntax correctly and so on, and it needs functions because it's going to be calling functions from package A, then so package B, then I need B to be compiled and done. Now, if B, on the other hand, needs A to be compiled and completed because it's going to be asking for functions from package A, well then, you know, I gotta, we got a catch-22 thing, okay? And I'm not going to be able to compile. Literally, I'm not going to be able to compile, okay? Because there's a cyclic dependency between them, okay? Now, the way things work is, okay, if you write a function A, in your code, and you compile, it's going to run. Everything is fine. If you create a function B that in it calls function A, and let's just say you haven't actually created function A, it's going to give you a syntax error because it's going to say function A is not there. Okay. Let's just say function A was there, but function A had a syntax error. Again, it's not going to compile B because it's going to say, well, the A that I was depending on, it's not working properly. There's a syntax error in it. The same concept applies between packages. All right. When I deploy a package, okay, so I have to see the one that is at the layer 0, so to speak. So this is the one over here. That's on layer 0. That one compiles first, then followed by this one, followed by that one, then followed by this one, followed by this one, followed by that one, followed by this one. All right. The one at the top is the one that is the absolute last one to be compiled. Okay. Because if there's an error in this one, there's no point in compiling that one. All right. It's going to stop my compilation right there. Okay. Assuming for some reason I have made a dependency between that bottom package to the upper package GUI. Okay. That means I have actually ended up with a cycle. So that's not good. That is definitely not good. Okay. I need to be able to fight this. I need to be able to remedy this. Okay. I can solve this in one of two ways. The first of which is figure out the common classes or the classes that actually GUI has needed from com error, and I take it out and I make that into a different package on its own, then make the other ones, the GUI and com error required. What does that mean? Let's go back again to the whiteboard. Okay, so here I am. I had, let's call it package A. Oh, let's call it over here. Package A, and I got package B. All right. So A, I know it needed some things in B. Okay, but then B requires some things in A. Okay, so let me just draw this quickly better. Okay, if I have some classes here, let's just put them in blue. Okay, 1 and 2. This is what package B actually wanted from class A. And let's just say put the other ones in purple, 3, 4, and 5. So 3, 4, and 5, B doesn't really care about them. Okay, what I can do is I can grab those two, okay, take them outside, create a different package, call it C, okay. Now remember, this line over here was for 1 and 2, صح? Right? So now this line, instead of it pointing over here, it's going to be pointing where? To the one at the bottom over here, because this is what it needed. It needed 1 and 2. Now, at the other hand, when I moved 1 and 2, they were here, and I moved it outside to C, suddenly A is feeling a gap. في فراغ. Okay, something is missing. It's missing its 1 and 2. Okay, so in order to grab its 1 and 2, then that dependency is going to come down as such. Okay, so this way A has access to 1 and 2, and B gets its access in for 1 and 2 without there being any cyclic dependency. Okay, everything is going into the one direction over here. Okay, whereas previously in this situation over here, I had a cyclic dependency. Okay, now the other way I can break up the cycle is to use an interface. All right, now here it is. I got A, it requires B, so X and Y requires B. Okay, if I zoom out, okay, let's just ignore these classes for a moment. I can see one is going this way and one is going that way. So it's causing me a cycle. Now what I can do is, I can get this Y over here, create an interface for it, just an interface, an empty class really, okay? And if I have an interface called Y interface, all right, that interface is going to be dependent on by class Y. All right. It's going to be dependent on my class Y because Y implements the interface. All right. Y implements the interface. And then this, sorry, I flipped it up. Sorry. The interface was for B. I apologize. Okay, so B over here has it's going to be implementing an interface called BY, but it's across state lines, so to speak. Okay. So the implementation, if you remember from the use case modeling slides, implementation and generalization is the same symbol as such. Okay. So B is going to depend on the interface. This over here, from the perspective of Y, is nothing but the old B, which we had over here. Okay, so this over here still remains the same. That line is that line over there. All right. Now let me move out to the white screen because I think I might have lost you with the way I was explaining this. Okay, so we had B, then we had Y. Okay, and let me just remember quickly. I think it was Y, yeah, Y that needed B. Okay, all right. So this part of the diagram remains the same. All right. Now what I'm gonna do is I'm gonna take this part over here. Let me use a different color. I'm gonna take this part over here. I'm gonna zoom out. Okay. I'm gonna take that B as is. Put it down over here. So this is my B. And then I'm going to create an artificial interface. Okay. So put it over here, call it B interface. Okay. Now remember, when we write code, we say class B implements B interface, correctly? That means the interface doesn't need B, it's B that needs the interface. So we have a line as such, okay? Because B is the one that implements interface, okay? Now this line over here is still pointing to the edge of the red line. Okay, so in other words, it's kind of like it's pointing to over here. Okay, it's just pointing to over here. Now the only difference is that previously this was one package and this was a different package. Okay, now what I'm gonna do is, right, that B interface over here, I'm gonna be moving it to the package that is contained in Y. Okay, so my Y is here. All right, and the red line, sorry, not the red line, actually, the purple line, which was coming straight down in the middle, I'm gonna move him just like this. So now the B interface comes with the Y, and the B class stays where it was. Okay, now from the outside, here's the most important part. Okay, from the outside, the most important part is that B is pointing this way. The direction between the different packages is pointing now from B to the package that is contained in A. So the general direction now is that way. Okay, and if we go back to the slide over there, okay, now from the B part, I'm moving this way. From the A part, I'm moving that way. Both of them are pointing into the same direction. I've broken up the cycle. And that would be my second way to break the cycle. Is this clear? Good, good. Guys at home? Okay. All right, good, good. Now, the next up, we have something called the stable dependencies principle. Now, in general, we want to be depending on what's stable. It's almost like an analogy to regular life, okay? You don't want to depend on something that's volatile. You don't want to depend on something that keeps changing frequently. You want to depend on something that is stable, even if it's not the best. You want it to depend on something that is stable, doesn't change all the time, doesn't change frequently, doesn't get damaged, it's reliable, okay? You want to depend in the direction of stability. I mean, you have a package and I have a different package and I have to have this coupling, something that I don't like. But at least if I kind of have to have this coupling, gotta depend on something that is stable. Because if this one is not stable, that means it's gonna change a lot. Okay, the deltas in it's gonna be a lot, which is gonna cause this one to change a lot too, as well as everything else that depends on it. Okay, it's gonna be a snowball effect. Okay, now what I want to do is I want to have dependency on something that doesn't change a lot, so it is quite stable. Okay, now stability is looked at from a different perspective here, other than just the frequency of change. Okay, let's just take a look at the stability with respect to a symptom. Okay, now that symptom is saying, what if I have a class and I know it's very difficult to change, okay, then it's less likely that I will change. Or I have a package that is very difficult to change, then chances are it's going to change less frequently. So despite this saying it has nothing to do with the frequency change, it actually does, but we're going to look at it from a different perspective. Okay, we're going to look at it from the perspective of how difficult it is to change. And obviously we're going to make the logic of the more difficult it is to change it, the less likely and the less frequent it will change. Okay, if it's easy to change, maybe I'll change it once a day. If it's very difficult to change, maybe I'll change it once a year. All right, and one of the ways that makes a package difficult to change is if there's a lot of other packages that depend on it. Okay, now imagine you're working at a company, okay, or you're looking at a company, okay, you have an employee. Everybody in that company depends on that employee, depends on the production and the work that an employee does. All right. Chances are this employee is unlikely to be fired anytime soon. Right. It's almost the most important employee in the company. All right. So one way to make that employee stable is to have a lot of people depend on it. Okay. So if this is my employee, I'm going to make a lot of packages depend on it. Okay. Because a change in X here is very expensive. It's very expensive. Okay. Take a second scenario. The second scenario is I have X as such, nothing is depending on it, nothing, it's, and it itself is not depending on something else. It's neutral, okay? It's not helping me per se, in the sense that it's not helping the other packages, yet at the same time, it's not an extra weight on the other package. It's holding its own weight. Type. Let's take the third scenario, which is this one over here. I have an employee who's a burden, okay? That employee keeps depending on 50 other employees in order for it to do its job. Probably the most unpopular employee in the whole company. If they would take a vote to see which employee they want to kick out, it would be Y, all right? So X is the most loved. Okay, let's just say Z here, no dependencies, nothing here and nothing here. It will be neutral. Okay, this one over here is the most hated. Okay, but also, why is it most hated? Because if I make a change in this one over here, make a change in this one over here, make a change in that one, any one of those will trigger a change, a redeployment of Y, because depending on it. All right. Matter of fact, if I take this to the nth degree, any one of the packages that Y depends on changes, I have to go back and redeploy Y. Okay. Now, on the other hand, if I go back over here and I take this one to the nth degree, if I happen to change X, I'm going to have to redeploy a lot of other packages. So I'm going to think twice, 3 times, 100 times before I make any changes to X. Z, on the other hand, neutral. Okay. It's the same. So yeah, Y is a problem for me. And this is why, had I wanted, because every time I make any change to the one at the bottom packages, I always have to update and redeploy Y again. So Y is one of those burden packages, and I don't like it. Okay. I would call Y unstable. Okay, because any of the change at the bottom causes a change in Y. And I would call X stable because it's very difficult to change because of so many other packages depending on it. And because it's very difficult to change, that makes it stable. That makes its frequency to change actually very, very, very low. Okay. So my formula here for stability would be a ratio between the incoming arrows and the outgoing arrows. Okay. Now we have, like I said, the neutral situation over here. All right. Fine. Because what's coming in is the same as coming out, which is actually 0. Okay. If I have one coming in over here, good, stable. But if I have one that's leaving, okay, makes it a little less stable. But again, 1 and 1, 50-50. Okay. All right. Here, 2/3 coming in, 1/3 coming out. Okay, you see the ratio? Okay. Have another arrow coming in. Again, we're back again to neutral. Okay. Think about it as, yes, I'm an employee that I depend on some people, but also some people depend on me. Okay. Also, if I get a lot of people depending on me, great, I'm happy. But at the same time, if I'm depending on a lot of people, that's also not good. Right. But back again, I'm back to 50. Had those lines at the top start to disappear, we're looking more towards this one. Okay. Yeah, only one person depending on me, but I'm depending on a lot, which means that anything at the bottom here changes cause me to change. Okay, and vice versa. If the ones at the top, at the bottom here disappear, and I'm having what? So it's not as extreme as this one. I am depending on something else, but I'm only depending on one more, and it's only when that one more changes that it caused me to change. Yet at the same time, I'm better than the neutral Z because I have 5 people depending on me. Okay. In other words, the formula for dependency is a ratio. Okay, it's something called the afferent coupling, which is the number of classes outside that depend upon the classes inside my package. So incoming dependencies. Okay, so this is the incoming dependencies. Afferent coupling is the number of classes outside the package that classes inside my package depend on. So it's the outgoing dependencies. Okay. Now, afferent is referred to as CA. Afferent coupling is C. Okay. And basically, as you can see, I'm adding the total at the bottom. So that's the total. Okay. That's the total number of lines in and out. And at the top is the percentage, the ratio of the ones coming in. Okay. Now, if the ones that are coming in are very high and the ones that are leaving are very low, okay, so it's almost like this is very high, this is very high, and this is very low, then the total, the number that I'm going to compute is going to be almost equal to, if not equal to, 2. Guys at home, help me out. At least you also the 2. This is as grade 5 math, guys. Grade 5 math. All right. So here at the bottom, guys, okay, this is total number of arrows in and out. Okay. This afferent is the one that are coming in. In other words, I am computing the percentage, the ratio of the ones coming in comparison to the total number of lines total. Okay. Type. We have a situation where the number coming in is high, the number that are going out is low. Okay. This number that I'm going to compute, guys at home, it will be equal to what? Just put numbers. If you're really, really that messed up about it, just put numbers. Any numbers, and do the math in your mind. This is ABC math. Guys at home, I'm scared that you guys are not answering this question. Just put numbers. 1, 2, 3, how? CA is this is the same number as this one. It can't be 3 different numbers. 2 to 3. Okay, I said CA very high. That this is your idea of very high and very low. Let's just pick a big number. 100, 1000. Okay, Amana Hena A 1000. C is very low. So low it's 0. What's the answer? 1. Okay. All right. Now, if what's coming in is exactly the same as what's going out, okay, then what's the computation? What's the output? Yes, 0.5. Okay. So let's just say 3 coming in. Whoops. 3 coming in. Okay, this is my 3, and I got 3 going out. If it's always equal, then the top is always going to be half of the bottom. Okay, so your number is 0.5. So that's straight in the middle. That's the neutral. Okay, let's just say what's going out is much more than what's going in. So CE is very high, CA is very low. What would be the output? All right. The result is always going to be between 0 and 1. It's a percentage. Okay, this is why when you set 2, it cannot be 2. It cannot be 200%. Type. So guys, anybody answered? In case what's going out is very low, sorry, it's very high, and what's coming in is very low. What would be the number computed? Anybody has an answer? Yes. Okay, so let's just say this, let's just say this is 1,000, this is 1, and this is 1. What's the result? It's 1 divided by basically 1,001. It's almost 0. It's almost 0. So the range here is from 1 to 0. 1 is very stable, and 0 is not stable or unstable, whereas 0.5 is neutral. All right. Guys at home, hopefully that is clear. The last principle we're going to be looking at is the stable abstractions principle. Now, the concept behind this is that if I have the higher the abstraction level of a class, the less likely it is to change. Okay. I think I gave an example of this before. I have a class here at the bottom. This is Toyota Camry Blue 2020 GLE. Okay. Type. One level up, Toyota Camry Blue 2020. One level up, Toyota Camry Blue. One level up, Toyota Camry. One level up, Toyota. One level up, even vehicle. Okay. If I look at the very bottom here, Toyota Camry Blue GLE 2020, that is gonna change every year. Okay. So if I'm a client package outside, I'm depending on this one, then my dependency is very weak because I'm depending on something that is going to change very, very frequently. Now, if I really didn't need the blue and the GLE and the 2020, didn't even need Toyota to begin with, just I wanted to depend on the idea of vehicle. All right. And I just make that over here. I'm better off. Why? Because the concept of vehicle in general is unlikely to change anytime soon. Okay. So it's so abstract that it's unlikely. Yes, it's less useful, it's less specific. Yet at the same time, if I really didn't need the specifics, I just needed to depend on the concept of a vehicle being there, then I should be depending on what's more abstract. Okay. Now, this is not a class. This is a package. Okay. And so my package, it has classes in it. Let me go back again to the whiteboard. Okay. So this is my package. And I have classes in it. And I'm going to judge the abstraction level of my package based on the classes that I have inside and how many classes inside are abstract and how many of them are concrete, because I'm looking at the package level. Okay. Looking at this situation over here. Okay. That's all concrete. This is one extreme. Okay. Let's take this. Copy. I can't make it paste for some reason. Just a moment, guys. Yeah. Just drawing it myself again. All right. I have a class over here, and all of them are abstract. Okay. Whoops. So if somebody is depending on this one, and all the classes inside are concrete, all of them are very likely to change, then this package X is likely to be redeployed because so many of the things that it's depending on are volatile and they're going to be changing very, very soon. Okay. If X was pointing at the one at the bottom, all of the classes that are inside are abstract. The package as a whole is unlikely to change because all the components that are inside it are unlikely to change. So X would be unlikely to change anytime soon had it just been pointing at the bottom one, not the top one. Okay. Third situation, right? I have 3 are abstract, 3 are concrete. That's midway. That's midway between the top one and the bottom one. And again, it's a ratio that goes from 0 to 1. Okay. How do I calculate this ratio? You ask. No, not this one. 0 implies that the package has no abstract classes at all, whereas a value of 1 implies that the package contains nothing but abstract class. Okay, so A divided by A plus C. A is the abstract classes and C is the concrete classes. Let's just say I got many abstract, 0 concrete. Okay, that's 1,100 plus 100 plus 0, that gives me almost 1. Okay, vice versa, if I have almost nothing that is abstract and everything is concrete, so that's, for example, 1 plus divided by 1 plus 100, that's almost equal to 0. Okay, so again, just like these stability metric, I want to be for the stability metric from 0 to 1. Here's my package X. I want to be pointing at what's closer to 1. For the abstraction metric, again, from 0 to 1, I want to be pointing to the one that is closest to 1. Guys at home, is this clear? Everybody at home, anybody at home, is this understood? Looks like nobody's at home. If it's not clear, if you want to ask me a question, you can go ahead and ask now. All right, so I'm gonna assume that there's no more questions.